Hello, everyone. My name is Nikola Besinovic from Delft University of Technology. I'll be talking about the first results we got from our Rails project, which is a joint work with Chini, University of Leeds, and Linnaeus University. And I'll be talking about AI in railway transport, where basically we tried to lay down the foundation of railway AI research, try to understand the current developments and pinpoint some promising research directions. So if you look at AI around us, we can understand that being exposed to it in our everyday life and pretty much everywhere, from our phones and our cars, via virtual assistants to medical diagnosis. And what we can see is that AI market is growing with time and is expected to further grow, and together the revenues are ever increasing, and we can expect to see even newer and more novel applications in new domains. If you look at railways and try to understand how AI can contribute there, well, we see in railways there is an increasing demand for transport coming from passengers, but also from goods. We have complex route networks, and our operations are already pretty dense. And we have quite significant challenges in taking that all under control. Next to that, railways is one of the most sustainable modes of transport, and as such should be promoted further and used in a most efficient way. Another trouble that we are experiencing is that we are having shortage of staff, from drivers and maintenance workers to dispatchers. So there is even a higher need for automating various processes in railways. And some good examples of existing initiatives exist, like Smart Rail 4.0 or Digital Rail in Germany. So what we did in our research is focused to railway as a whole, and particularly to 7 subdomains, being maintenance, inspection, autonomous driving, revenue management, transport policy, passenger mobility, safety and security, traffic planning, and management. And we wanted first to give out a definition of AI, which would be sound for railway practitioners, to introduce AI taxonomy and make relations between AI and railway transport. For that, we used scientific papers and looked into industrial implementations, and not only in rails, but aviation, road, and supply chain, so similar domains. And that helped us to distinguish between existing applications and future applications. So looking at definitions, basically we try to see what does exist around first, and understood that basically various definitions are there already, but they often tend to capture a broad nature of AI and try to cover various parts, and sometimes they are really specific to certain domains and areas. And overall, they tend to be rather abstract and difficult to grasp, and therefore it would be difficult to have a wide acceptance. So we wanted to look at it from a railway perspective, and for that we introduce some key terms. First being aspects that includes algorithms, formulations, and technologies like optimal trajectory algorithm or prediction model or unmanned vehicles. So an entity would be a software or hardware or a hybrid of it, so like a train or a signal or a switch, and experience that comes from environment. It can be done via learning or data-driven inference. It can come from engine or traffic or track conditions. So by AI, we refer as to a discipline that gathers all the aspects that allow an entity to determine how to perform a task and take a decision based on the experience matured by observing samples or interacting with an environment. And what else we can add on this is that we could have these entities either competing against each other or cooperating with other entities. So one example is to have an algorithm for automatic train operation, which is mounted on a train and that needs to learn from track and engine conditions in order to design the optimal train trajectory. There can be various other examples. So we looked at the AI taxonomy and we used the UML class diagram to establish formal connections in between elements, and we form three main classes, being a research field, application, and techniques, and they have different interactions with AI. So first of all, the research field represent areas that rely on AI techniques, and they would not exist without them. Some examples are expert systems, data mining. By AI application, refer to cross-domain areas that leverage on AI to improve its performance and usability. And here we can think of operations research, image processing, computer vision. And with the techniques, here we gather methods, algorithms, and approaches that enable systems to perform tasks commonly associated with intelligent behavior. And here we see machine learning, evolutionary computing, and similar. So what we did, we crossed the Rails subdomains versus AI classes and distinguished between existing applications that are already present in railways and potential that could be found in other domains and possibly translated to railways, but not in railways yet, and uncertain, where no matching has been found in the other domains. So then we got tables like this, where, for example, for safety and security, we found applications for railway accidents using NLP. So in the coming slides, we present existing applications per each subdomain, and then give some future directions. So if you look at the existing applications, we see that majority has been focused on the maintenance inspection, around 57%, and then it's followed by traffic planning and management, and then only smaller portion of safety and security, autonomous driving, and passenger mobility. And yet, revenue management and transport policy, there are no AI applications still. So if we go now through each of these, you can see that in the maintenance application, we see various problems being tackled already, from detection to diagnosis and predictions. This could be done for finding defects like scratches or cracks or missing components. And also we see some first applications of autonomous activities. And the papers are addressed rail, heads, joints, switch, or wheels. And the most common techniques are machine learning and deep learning for these problems. And some small, simpler examples of dynamic decision support systems for scheduling of maintenance and inspection do exist. We see a combination of autonomous systems and AI for performing autonomous maintenance tasks, which is one of the first applications of this kind. And what we observe is that it's actually difficult to identify the best approach for each of the tasks because they highly depend on data sets and its processing. So we still need more effort to converge there. Looking at safety and security, main problems that have been addressed are object detection, incident analysis, and station security a bit. And for doing so, computer vision and image processing have been most often used. And we see some applications of expert systems that combine rule-based and case-based reasoning to allocate safety resources more efficiently. And sole example of using NLPs for accident reports has been recognized. Basically, that uses text processing to read out non-structural reports. Looking at traffic planning and management, typical problems addressed are traffic predictions, timetabling, rescheduling, and shunting. Looking at predictions, they mainly focus on the railway lines, so not networks yet, and they provide some initial promising results. So looking at timetabling, we have intelligent knowledge-based reasoning and decision-making applications in some earlier days. And more we see machine learning-based optimization approaches that tackle drawbacks of OR and heuristic models. We mostly see reinforcement learning being used. So all these applications mostly address toy and simplified problems. So more research is required, and some serious development is still needed. Yeah, as a positive example, I want to stress here that promotes AI developments is a competition organized by Swiss Railways for dispatching and rerouting using reinforcement learning. When looking at autonomous driving and control, problems usually around driver advisory systems and autonomous train operation. We see applications use the genetic algorithms and reinforcement learning to improve autonomous driving. What is common for these papers is that they mostly focus on theoretical simulations, while they lack using realized traffic data. And there is limited research on non-vital control systems. So passenger mobility, again, a limited number of research and mostly focuses on short-term predictions. And there is one work on addressing passenger experience. So mostly see different variants of neural networks being convolutional or recurrent NNs, and basically results and these studies vary significantly in features used, in metrics, so it's really difficult to compare them. And we see an application of NLP to evaluate passenger satisfaction with operations, extracting information from social media. And there are different future research directions, well, multiple. First, promising ones coming from existing applications from similar domains. I would like to point out two of them in particular. One being using autonomous systems for maintenance. There we can use unmanned aerial vehicles like drones for efficient and regular inspections of railway resources like tracks, catenaries, power systems. And when doing so, drones could be automatically find the routing in the network and visit the most critical resources. And the other one is operations research for traffic management. Basically, our problems are combinatorial problems, and AI, or particular machine learning combined with OR, could overcome existing problems of optimization models that could help us solving problems faster, so to be more suitable for real-time application, and as well address larger instances. And then more challenging directions that we don't find around us yet. Multiple, like computer vision for traffic management, operation research for safety, but to stress one that is trustworthy AI for automated driving. So we are familiar with the trolley problem, and basically we need to develop various regulations and standardized certification process to precisely quantify the trustworthiness of AI-based system in order to provide safe autonomous train operations and important safe performance to be achieved. So we need to follow explainable AI approaches here. So the main takeaways I want to leave you with is one, that railway and AI are still at its early stages of development, except maybe maintenance and inspection. There is a great potential of AI applications for future railways. Data quality and availability needs to be ensured in order to support the further uptake of AI. For that, we have recently reviewed publicly available data sets, and there is a need for regulations, in particular for drones and automated train operations. And the focus needs to be, in our belief, towards simpler but more understandable models and approaches. So that will be all from my side. To stay tuned on new research coming from our Rails project, here is the link. And with that, I would like to thank you for your attention, and I'm here open for questions.